Hello, welcome all. So I'll introduce to you to today's talk from Guido about how to reuse all storage, all hardware with CloudStack.
Okay, well, good morning. Morning, and online, of course, as well. So, some of you might have been in London where I gave the same talk. I tweaked the talk slightly because I got more information since we did a talk last time. So, a bit about myself first. Working at a Dutch hosting company for more than 20 years. Very open source enthusiastic. Work a lot with Ceph, with CloudStack, and I think we should implement IPv6 everywhere. So that's a task for you, everybody, to do so. Now, the company I work for is Your Online. We have hosting companies throughout Europe, big presence in France, in the Netherlands, and in Spain, and expanding towards other countries, I think this year, and probably next year as well. But we use CloudStack and Ceph a lot for the environments we run. Mainly in Spain and the Netherlands, we have large deployments of CloudStack and Ceph. So, yeah, indeed, our large infrastructure is powered by CloudStack, Haarlem and Amsterdam, although people refer to Haarlem as Amsterdam from abroad, but Wayne knows the Iron Mountain data center of LeaseWeb, that's always referred to as an Amsterdam data center, and in Valencia in Spain. So we have hundreds of hypervisors running thousands of virtual machines, but we don't like to throw away properly functioning hardware. It's a waste of money, so the financial people like it, but it's also pretty bad for the environment, and we care about both. That's the honest answer. We care about the money, of course, and we care about the environment. So let's take a look at servers. 5 years old. Are they old servers? Do you think they need to be thrown away, need to be replaced? Who replaces his servers every 5 years? Because it's company policy. Okay, nobody's doing so. But if you look closely at a 5-year cycle, as I've written here, is that vendors are telling you that you need to replace everything every 5 years. But actually, they will operate for about 4 years. You have 6 months from delivery to production, and then before they hit the 5-year mark, you want to start replacing them. So you have a 4-year window where the machines are operating, and then are not even operating at their full capacity for the full 4 years. So, yeah, as I said, replacement before they go end of life in a financial perspective after 60 months. But is it really wise to do so? Well, I think it's not, because that's the whole point about this talk. Because we can look at a few things. There's a global warming potential for greenhouse gases. There's a carbon dioxide equivalent. The equivalent means that we have other greenhouse gases like methane, which have a higher warming potential than CO2, but they calculate it back towards a CO2 equivalent. And a lot of products have a product carbon footprint. You look at Dell. Dell does it very, very well. They also have a life cycle analysis of the servers you buy from them. You know how much CO2 equivalent is emitted when producing those machines. So let's take a look at a Dell server. Running time 4 years, operational 24/7. The global warming potential is 8.5 tons of CO2. Which this machine emits over its 4-year life cycle. And this is information which Dell provided. You can look at other machines of Dell, the RS6515, running the AMD EPYC, and you see that actually the manufacturing process is quite a big impact of the server itself. There's of course the use, and there's a bit of transport and the EOL getting rid of the machine, but the production of the machine has a very high impact on global warming. Why we're producing chips, the metals which are being used to produce your machine. And you can find this in the life cycle assessment of Dell servers. So just Google for life cycle assessment and a model of machines you're using. And again, Dell was really good at this and publishing these numbers. All the manufacturers will be actually mandated to produce these numbers and publish them. But it is an impact we need to take into account. But what if you would run your service for a bit longer? So there's a part where you have no influence. That's the production part of the machine. If you run for 4 years, it's about 50-50. If you start running the machines for a longer period, there's a part where you have an influence, because that's the energy they are consuming while they're running. What we've seen over the last few years is that CPUs are becoming faster and faster and actually more energy efficient. But it also slowed down a bit in the fact that a CPU from 6 years, 7 years ago, can still work just fine for many applications. Sven, we were talking about this yesterday, that an E5 CPU, an Intel E5 CPU from 6-7 years ago is still fine to use for a lot of applications. And when I talk with engineers, they say, yeah, but you need to buy the new servers because they're more energy efficient, and so that's better for the planet. Well, actually, if you look at this part, it doesn't really matter that much. You can run servers, older servers, and be much better for the environment. Of course, it depends per your energy mix. If you, it depends on where you are on the planet. However, if we look at the part where there's no influence, and then we can see that if you're using a machine with SSDs, what we're doing, 80% of the CO2 emissions come from the SSDs. Those are the most horrible to produce if you look at CO2 emissions. And I'll get back to that in a moment. So 80% is just the SSDs. Because there's a paper from October this year, you can Google for this, I have the quote here, is that for a single gigabyte of flash memory, 0.16 kilograms of CO2 is emitted. So a 1 terabyte SSD has 160 kilograms of CO2 emitted as a footprint, a 1 terabyte. So go towards 2-4 terabytes, whatever you might be using, you'll see they have a major impact on the environment, SSDs. And they got the same numbers from all kinds of different research. It's a good paper, I think it's like 10 pages. But you can see here, they come up with the same number. In a server, about 80% of the CO2 emissions come from the SSDs, not from the rest. And if you would look at a equivalent with hard drives, the number would go down to about 38% compared to 80%. Hard drives are much better for the environment than SSDs are. So we were looking at the part where we had no influence. This part where we have influence, of course, which is energy. But then you can also look at the CO2 emissions which countries have. The European Union, they publish information about the CO2 emissions for a kilowatt hour. Well, the country where I'm from, the Netherlands, we're not doing that well with 418 grams per CO2 for every kilowatt hour which is produced. Countries like France, for example, do much better. There's a lot of nuclear power in this country here. So those kinds of things need to be taken into account as well. But it's a no-go, right, using refurbished. Engineers will always ask, I need the newest, the most shiniest machines because that's the best. We need to spend a lot of money because if we spend more money, we get better machines, and spending more money is just better because then you have the best stuff. Well, if you look at it from a different perspective, you save 50% in the CO2 because you're simply not manufacturing new machines. It's also significantly lower on CapEx. It can be 50%, usually 30%, depending on where you buy them, if somebody has tested them for you and did some proper refurbishing on them. But if you buy them second-hand, it could even be going beyond 50%. And my opinion is that you should have, your customers are asking for a service and you need to deliver the service. If that's of hardware 5 years old, 6 years old, 7 years old, well, I think it doesn't matter as long as you're meeting the SLA which you have agreed on with your customer. So take a look at refurbished machines, and there's a big market out there where you can go and just buy refurbished servers. And I would also say they're battle tested. In the last 2 years, we've been buying a lot of AMD EPYC systems as we were throwing out a lot of really old hardware. But I found that the stability of these new machines for the last 2 years was pretty bad. We were buying Supermicro and Dell, all kinds of glitches and crashes, and we needed to do BIOS updates, microcode updates for the CPUs to get them stable. But the refurbished machines we've been buying, they've been much more stable than actually the new machines we bought. So I would say they're battle tested. Okay, but we're on the CloudStack conference here, so why we're talking about CO2 emissions, right? So tell us something about CloudStack, right? That's the whole point. Well, CloudStack has a few interesting things you can use for determining which service needs to run on which hardware. And it's the tagging. I think Sven, you mentioned, I found from We Systems, they said we're using different types of hardware in the same CloudStack environment. Well, we do so as well. So let's take an example of our environment in Amsterdam. we have many generations of hardware, the Intel Xeon, so the E5, the Broadwell, the Scalable, so the Skylake CPUs, and the AMD EPYC generation 1 and 2. So we came up with an idea of having an offering. Tier 1 is always the latest generation of hardware. In our case, AMD EPYC. But there's also the Intel Xeon Scalable, because we acquire companies which might have gone for the Intel Xeon Scalable. So they're called Tier 1A, Tier 1B. And the tagging we use, it's still Tier 1 tag, and then the Tier 1A and a Tier 1B tag. Well, you can read the table here. So we go down towards older generations, even have E5s, V2, and V3 CPUs still running in the environment. So the service offering with the T1 tag, so you can go very specific saying, I want this to be running on an AMD EPYC, T1A, or you said, I just want a service offering with proper CPUs, which is the latest generation. I'll go for T1, so Tier 1. High performance websites like e-commerce, which really need a low first time to byte, Tier 1, but many back office applications, Tier 2, and spam filters, they can run on Tier 3. It's not needed to run them on the latest generation of hardware. So we try to use the hardware as long as possible. That is our goal. Again, SLA, uptime, that's something which we benchmark, we check if the systems are still functional. But it's not that we say that hardware needs to be replaced every 5 years. And how do we do so with live migrations? Well, the same types of hardware are in the same cluster. So in the Amsterdam data center, one of the locations, there's a rack, room 138, A05. These are Supermicro 1Us with the AMD EPYC generation 1. And then we have all kinds of different racks. So per rack, we have a generation of hardware in one rack, and that's one cluster inside CloudStack. So within the cluster then, you need to make sure that in the KVM agent, you set the CPU model to be identical between all the nodes in the cluster. So live migrations work as expected. Indeed, so same CPUs in the same cluster, which is one rack in our case. And if we start a new cluster, we use a new rack. So you'll find some of our racks are really full with a lot of machines, but some can only house 10 machines because this rack is limited to 32 amps, and those AMD EPYCs, the machines consume about 1 amp, no more than 2 amps per machine, so we can fit 10 machines in one rack and then it's full. But some other generations, we can put more machines in a single rack. And yeah, we've been using Dell most of the time, but we have a lot of Supermicro as well. So this is the racks we have deployed in Amsterdam, Valencia. And I really recommend using colored power cables. That's something, I find it cool, but it's also very beneficial to see that all the cables are connected properly. Just as a side note, because why? I've seen that if these were black cables, I've seen that some people made mistakes when pulling in the machine. So one machine will be connected to feed A, one machine will be connected to feed B. It was all beautifully cabled, but with black cabling. And then one feed went down, and then a server went down because there was a mistake with cabling. And that's something, an oversight, you see very quickly when you're using colored power cables. It's a lesson we learned the hard way a couple of times. So colored power cables, much better. Anyway, we also use Ceph. And Ceph is designed for failure. So why should we buy the newest hardware all the time for Ceph? Again, I even think that older hardware is more stable than the newest one. Why not use refurbished hardware for a Ceph environment? Does everything require the highest performance? I don't think so. So we run a few Ceph clusters. We're still with SATA-based SSDs. And they work just fine for back office applications. No need for high performance. Just run. And I think we have the oldest cluster now hitting 8 years. And still running just fine. It's 10 gig based environment, updated to the latest software, and just running and running. So occasionally replace an SSD, but only when needed. So my summary is, and my main point here is that hardware production has a significant impact on the environment. It's not often talked about, but it's something which you should be aware of. So you can use host tagging to do cool stuff, but older hardware can still be used, and think twice before replacing equipment. And also think twice before, let's just replace all the SSDs. Because I'll go back to this one. 80% of your CO2 equivalent of the production of a machine comes from SSDs. They are really cool with performance, but really bad for the environment. And then there's an open question for the community. Do we actually know how much kilowatt hour CloudStack consumes? Do we know how much a single trillion run uses when we do something on GitHub, or a blue orangutan run? If you ask, can you please test my pull request? Do we know how much CPU power is being used and how much energy is consumed? I don't know. Maybe it is something we should try to find out as a community, as a project, and publish about that. Okay, are you sure you want to run this test because it's going to emit so much CO2 and consume so much energy? Do we ever think about it as developers? Because CI/CD is really cool, right? We just build all day, let it building and testing, and we do one commit and the whole shebang goes again, and we start testing everything. But is that really required? So maybe it's time to start thinking about this as well, that doing a commit and having it tested is fine, but maybe you should think twice before asking a testing environment to run it. Because yes, it runs on a server far, far away doing the testing for you, but it is consuming electricity, which in turn is actually producing CO2. So that is happening, it is real. So kilowatt hours, you probably know what they are, so I found an image about this. But maybe we can find out or make an educated guess and inform users and tell people saying, hey, this is the impact of a single test you're running on CloudStack. So my main point is just awareness. Be aware that hardware has a major impact on the environment. Think twice, save money in your wallet, save the environment by using hardware a bit longer. So, thank you.
Thank you, Guido. There are no questions from the online.
That's fine.
Any questions from the room? Anyone?
My question is, when you have to replace some hardware, for example, after 10 years, will it be a nightmare to replace the hard drive of Ceph cluster?
Well, no. If you look, those Ceph clusters which are running SSDs, they used to be running on the Samsung PM988, with the 8 something starting with an 8 PM8. Samsung is still producing SATA SSDs for servers, and they're now the 9 series. So whenever an old hard drive, an old SSD fails, we replace with a latest generation of Samsung SSDs. And they might have a slight performance difference, but you don't notice on that back office application.
Thanks.
And the thing, I think what we did is with our racks is that we have, so one generation of hardware of hypervisors, but the same goes with Ceph. There's only one Ceph cluster in one rack. If we build a new Ceph cluster, it goes into a new rack. So the cabling is also still very nice per rack.
Thanks. We have a new question from the online, from Joseph. Do you buy single CPU servers for Ceph because of NUMA, or 2 CPUs are fine as well?
Oh yeah, it's a Ceph-related question. We do use one CPU, the AMD EPYC. So indeed, NUMA makes life much easier just using one CPU. So we use a single CPU. Yeah.
Great. Thank you, Guido.
Okay. Thank you.
Thanks.